I just took the concrete class, and it will be a pretty much repetition of the, especially with the modeling. So those who have who were in my concrete class, bear with me. It's a repetition. Okay, little bit, some portion. Okay, the other things are more or less same. Okay, let's start with that. Anywhere we need to start with a model. Okay, any only difference between RAM with RISA or any other softwares is RAM actually analyzes and designs. Okay, RISA mostly an analytical tool. SAP is an analytical tool. Okay, the difference between RISA is RISA you have to give the inputs like what type of beam sections or what type of column sections you want. RAM actually chooses that, so that's the advantage. Yes.
Can you import any of the 3D modeling files into here?
Yeah. From Revit.
Or how about Rhino? That's 3D.
Rhino, I do not know what is that, but I work with Revit. Yes. Can you make a DXF file from the Rhino?
I'm not sure if I can find out.
I mean, I know Revit, CAD, MicroStation. These are the where you can make a DXF file. You can import the files as a DXF file. Either 3D, 2D, floor plans, whatever. Again, I'm saying it in terms of Revit because that's what we use all the time. We bring the Revit file and analyze and design it and send it back as a Revit file also. Okay, so you can do that. Okay, let's start. So any software you need to have a file. So let's create a new file, which is this one. And sorry, I need to go to my steel design class, fall, lecture. And building 1, units, feet pound seconds, so that's the one we will use. Save it. Okay, so it will come up with this background. So anything what we need to do is for a building design or any design, we need to set up the model or we need to develop the model first. So we need to calculate, click on that, but before clicking on that, I want to check a couple of things on the criteria part. So if you click on that, member loads based on IBC, especially it's the live loading. It's basically IBC is International Building Code, and we use CBC, which is California Building Code, a modified version of IBC. Okay, just a little bit changes, not total changes. Other than that, we will use the default. Read those things. Okay. Self-weight for us. The thing that for any structure, it will analyze and design the beams and it will calculate the self-weights also. I personally like to unclick that one because I usually give as a additional load like 75 PSF for the floors. Remember in any of the example problems, 75, 80 or 60 PSF. Those are the additional dead loads on the slab. I like to give them as a superimposed dead load rather than the program to calculate it. Only reason is on top of the slabs we have additional stuff like finishing. Sometimes marbles, sometimes tiles, or sometimes just concrete grouting. These have self-weight, but the program will not calculate that. So that's why I add additional loads and I'm unclicking this one. Okay? And if you see master table, that means RAM itself, RAM AISC, RAM AISCCM, or RAM will actually use them. Sure. Okay. Now let's make the model. Click on the modeler. It will come with a open space like that. That means it's kind of like a blank. Now what we need to do is, for the modeling purpose, is we need to give a platform for the model. That means we will place our beams and columns in one of the floors, and which we will call it as a typical floor, and then copy all the floors above. Usually, I mean, in an office building, most of the floors are the same. Okay, only thing maybe the roof and the foundation is kind of like a roof, and the first floor is a little bit different. Second, third, fourth, fifth, sixth, mostly same. So we will draw, or we will design one of the typical floors and copy it. If we need to change something on the top or on the bottom, we can change it going once we are done with the copying part. So what we will do is actually select or design a typical floor first and then copy it. So how we design the typical floor. What we will be doing is these two buttons, or what do you call that? Something. Layout is where we will place our beams, columns, everything, and prop tables means where we will give our section properties. Okay. By default, it's steel. If you want concrete, you can select concrete, but it's steel and it is a steel class. So go on to the layout, type what type of floor you want, select, and I'm going to say it's a typical floor. Add that. And once it's blue, it means it's selected, and select. Now if you see, there is a select typical here, that means my platform is on a typical floor level. Go layout, type. Now remember what you said, import from the Excel file, that's the one you would be interested. Now before you copy or DXF, what you need to do is actually model it. And any architectural designs or drawings we model it, it basically comes with the grid lines. That's the easy way to do that. So your columns, beams are actually placed on intersection of the grid lines or along the lines. So let's give some grid lines, create, give a name, orthogonal. You can give anything, your name also. Add. Now select that one. Once it's blue, edit grids. So what I'm going to do is look at any flashlight. Somebody had a flashlight. We will be modeling that one. Okay. That's the plan view, like grids, nice grids. Okay. A, B, C in the X and 1, 2, 3 in the Y directions, and that we will use that. Okay, thank you, flashlight. A, first coordinate is 0, 0, so that's okay. B, maybe 25 feet. Add C. Okay. Now, B, if you want to add C another 25, you have to give coordinates as 50. Other than that, what you can do is, since they are all equally spaced, you can generate them, and you can say I would like to generate another 5 of them. So if you see, B is 25, C 50, 75, and so on. Okay. So my X grids are done. Y grid, I will use the first one, 0, 0, and I'm going to generate. Should I go back? Got it? I'll generate 30 grid spacing and maybe 7 of them. Add. So if you see 1, 30, so on. So my grid generations are done. And I'm going to say okay, but I'm not seeing the grid. So what I can do is click on this one, select grid system. For a typical floor, you need to see the orthogonal. So click orthogonal and go on, and it will create the grid system. Okay. Now I need to place my columns, beams. Now, if you click on the layout, you have to go chronologically. That means you cannot, from grids, you cannot jump to beam. You have to go column to beams, horizontal braces, slabs, loads, and so on. So you have to go one by one, not like jumping from one to another. So grids are done. I need to place my columns. So what I can do is I can add my columns at the intersection of my grids. That means I can add columns here or somewhere. So add columns on grid. I can do that. Standard column 50 KSI. Maybe this direction is fine. Only thing is I am going to use first as a gravity columns all of them. Then I can change as a lateral columns once I need that. I can use a single. That means it it snaps at the intersection. Okay, but it's kind of like a time consuming, so I can do something else. Use the right click button and it will come up with the same dialog box, and instead of single I can say fence, and if I do that it will place columns at all intersections. Okay, are you with me so far? Okay, good. Yes.
Say you already selected a view. If you go over it again, it won't like a double.
No, it's not going to place over on top of it. It used to be in the 2006-7. Yes. Yeah. That was a bug that they fixed. It used to be given as a error that you have columns on top of another column. So they fixed it. Okay. Now layout. Go beams, and again I need to add beams, right? And I can say add beams. Let's start with gravity composite. Now that's composite is all of our gravity beams should be composite beams. The reason is our floor deck. By the way, if you need to stop me, please stop me. Don't hesitate that I will say something. Please, if you do not follow, stop me. I will go back and show it to you again. Some of you have already taken my other course, which is concrete design. So you already know that. So don't worry, those who are new or who just sat down on my previous class, this is the time you learn. So stop me if you need to talk to me or if you have some question. Okay? Don't hesitate. Where am I? Oh, we are trying to get some adding some beams. For the composite means, since we have a floor deck and floor deck has usually have concrete on top of that. So when the beam bends, it bends with the slab. And on top of if it bends as a positive bending, the top portion of the beam is in compression, and that includes the concrete part on the deck also. And as you may have known that concrete is very good in taking compression. So in those cases, what we do is we add that concrete portion to take some compressive force on the top, and that reduces our beam size. That means it's very economical, and we want that. And that whole phenomena is called composite action. That means the beam is not only a steel beam, it's also part of concrete is playing the game. That means it's a composition between concrete and steel. Okay? Our last class or last week will be actually based on composite designs. So we will say these are all composite beams, and we can use a single first, beam column to column, or if I right click and select the fence, what I can do is I can do like that. Okay. Now the question is, if you see, this is 30 feet span, this is 25 feet span. My steel deck cannot span more than 10 feet. okay, 10-12 feet. So I have to do something like I have to place some intermediate beams. Okay, so what I can do is I can place some intermediate beams, go layout, beams, add off grid, and go parallel and say that I want 10 feet, offset, add, click on the beam where you want another beam parallel to that,
Wait, so could you show me once again, how did you?
go layout, beams, add off grid, parallel to the beam, 10 feet, okay, and add, click on the beam, click another, click on the beam, click another. Now you can do that, but it's again time consuming, so what you can do is go layout, beams, add generation. You can say, if you click on that, number of equal spaces per beam, you want 3 of them, and if you say add, it will do that, it will do that, or if you click on that, it will do that. So what I'm going to do is quickly hit them. Okay, my beams are done. So far, it's okay. Okay. Now, what I need is a couple of things. This is for entirely a gravity system. What about my lateral system? Lateral system means who will take, these beams and columns are right now designed to take gravity load. But somebody in my building has to take the earthquake load and all the wind load and so on. So the way we deal with that we make some of the beam column systems as my frame beams, either moment frames or brace frames. Right? Why you are so quiet? Say something, yes. Okay, so what we will do is maybe we can do a couple of things. In this direction, I will say I will have these 3 bays as my moment frame, these 3 bays as my moment frame, this one as my moment frame. Okay, moment frame means all I need to do is change the beams to be gravity. Instead of gravity, I need to change them as lateral beams, and also for the columns, I need to change them as a lateral beams. So I can go here and say columns, change properties, framing, instead of gravity, let's say lateral, and do a fence. Once it is designated as a lateral, it will come up with a red line or red designation. So this is, the columns are lateral but not the beams, so I need to change the beams. Now you can use this once, this criteria, all the dialog box will come up, or you can click on this one and the same dialog box will come up. This is change properties for the beams, framing, lateral, fence. Okay. Are you okay with that? Okay. Now in this direction I will add some braced frames. How about that? In this direction, again, braced frames are also my lateral system, so I will change the columns to lateral, maybe 2 bays, 2 bays, 2 bays, 2 bays. Okay? Also, I need to change the beams to lateral beams, same way. This one, this one, this one, and this one. Okay, now look at these beams, columns. They are bending about their strong axis, but these ones, Are they bending about their strong axis? They are bending about their weak axis, right? Are you following me? These columns, this is bending about this way, right? That means it's bending about their weak axis. So I need to change the orientation of these columns also. So go columns, change properties, and only thing I need to do is change the orientation. Instead of this one, click this one, fence. I'm not changing this one because it's also part of the brace frame. Can you follow me? I changed this one, but not this one because it's also part of the brace frame. So which one is more important for me? I don't know. I'm just using brace frames are more important for me. It is true. I don't know. Okay. I know a little bit, but somehow I know that. Anyway. Any questions so far? No? Yes.
Yeah, can you show how you made the columns ready again? What was that part?
Either you click on this one or go to layout, columns,
Yeah,
change properties,
got it.
and instead of gravity, click on the framing. Instead of gravity, make them lateral,
Got it.
and then select.
Alright. Hey,
Yes.
Could you explain once again why those guys became lateral rather than
Blue. Well,
I'm sorry. Never mind. I'll ask later.
no, you can ask me now.
You said that you're pretty braced in the center area. For that reason, we needed to change the orientation.
Well, for this one, this is a moment frame, this is a brace frame. They are orthogonal, right? If they will bend like that, they will bend like that. So which one? Either you can change this one to this orientation or you can keep them because both are lateral frames. So since I have a shorter bay for brace frames, I would like to keep my column as a strong axis. This is like 3 bay, so I have more materials. That's fine. Okay. Also, I want to have my elevator core here, maybe another elevator core somewhere here. Okay, or maybe want to have my elevator core here. If I have an elevator core here, I do not need these beams. So what I can do is go click on the beams, layout, beams, delete some beams. Okay. So far, if I see my columns are done, my beams are done. Now horizontal braces, we do not give them now. Slab. Okay. Now before I give a slab, what I need to define is what is the perimeter of the slab. All of these lines are the center line of the beams, right? My slab cannot end at the center line of the beam. It has to extend beyond the center line of the beams. So I have to extend it like at least 10-12 inch. So I will define my slab edge as 12-inch overhang, and I will say whole perimeter. That means it comes up with a green line which shows me the slab edge, which is about 12-inch from the center line. Okay, click that. Okay. Now if I place the slabs now, it will be whole thing will be in a slab, but I need a penetration here, or I need an opening. So I will go layout, slab opening. Remember, I have chosen left overhang. It has to go from the center to 12-inch inside. So if I click on zoom in, look how I am going from one beam to one column to one here, and its overhang was on the left and it came out 12-inch overhang on my left side. If I go from here to here, it will be on the right side, which is wrong. Okay, so that's my slab opening. Okay, so far we are okay. Only thing I am not showing you, because these are movement frames, is fine. Beam to column connection is a movement frames, but these are brace frames and I have not given the braces yet. Well, I have to give the braces when we have an elevation. Okay, right now I'm just giving the typical floor, one floor level. I do not have an elevation view, right? Because there are not enough floors, the multiple floors are not there yet. So once we add the multiple floors, then I will give a braces for elevation. Okay, now I need to define what type of slab I want, deck assignment. But before I click on that deck assignment, I need to make sure that what type of deck assignment. So you need to go into the property tables and you need to define what type of deck you want. Okay, for a composite floor system, there are lots of options that you can choose. If I choose, I'll show you what type of the one we want. Okay, this is a Varco decking system, commercial, and if we go W2, W3, okay, PLW3 or W3 formula, 6.5 inch. That means it's a 3-inch deck. That 3-inch deck means the deck from bottom part to top part is 3 inch, and then another on from the top part we have another 3.5 inch of concrete on top of that. Okay, and its weight is 60.4 pounds per square feet, and depending on what type of or how thick metal deck you want to use, and we are going to use this one. Okay, that's a very common commercial deck. So, sorry, what was the name? W3 formula, right? This is the name of the deck. So if we go Varco W3 formula, that's the one we want. Label, okay. Concrete thickness about the fluid. What is the fluid? Fluid is this one. I have 3.5 inch. Stud length, what is the stud? I have to show you. Usually we place some shear piece like a bolts welded with the deck so that the concrete on top of that doesn't move. So those are called studs, and that has to be about 5.5 inch. It's not a lightweight concrete, it's a regular weight concrete. F prime C is 4 KSI. Stud FU is 65, self weight of the deck is 3 PSI. Effective thickness, if you see, is 3 inch plus 3.5 inch, so 6.5 inch. So effective thickness maybe half of that. Poisson's ratio is 0.23 or 0.25 or 0.2. Elastic modulus 3605. Take those numbers. You can take a picture of that and take those numbers. You use that. Okay. Say add. Done. Okay. So your deck assignment was correct. Deck properties are given. Now you need to add that. So slab, deck assign, and remember we choose this one. And now what is the deck orientation? That means deck direction. It's a one-way slab, right? And the deck has to run this way, right? Not this way. Are you with me? Huh? The deck has to run this way, not this way. So you need to change the orientation like that. Okay? And I'm going to use a whole float or whole diaphragm. Again, whole float means when it's used for gravity load, and whole diaphragm is when it is used for gravity plus lateral. So I'm using it as a, okay, and if you see the deck penetration or deck opening is still there. Are you with me so far? Okay. Now I need to give some loadings, right? Now before I give load, I have to define what type of load. Go to prop table and load. You will see that there is a surface load, line load, point load, snow load. Surface load means PSF loading. Line load is pounds per linear feet loading. Line load means wall loading. This is just regular PSF loading. So let's give a surface load, and I'm saying that that's floor load. Dead load, remember what was the weight of the slab?
145.
Huh?
145.
No, that's for concrete slab.
75.
75 PSF, right? In our class. How did I get that number actually? Again, this deck is 60 PSF, right? So I added another 15 PSF, which is like floor finish or tiles. Some weight for those. Okay? So that's why I'm saying that I'm not going to use the program to calculate the slab weight, but I'm going to give it. Okay? So let's give 75 PSF. Construction dead load is basically, construction dead load means during the construction, during the pouring of the concrete. Okay, the concrete has the weight, right? But the concrete cannot take any load. So it gives the load, and somebody has to take that load. Who takes it? The deck and the beams. When the concrete hardens, the concrete can take some self weight. But before the concrete hardens, it's kind of like a sitting there giving the load but doing nothing. Okay, so somebody has to take. That's what we call construction dead load. And during the construction dead load, okay, you do not have any floor finish because the concrete is not strong enough. So I'm using a 60 PSF, the concrete self weight. Live load, for our case, floor live load is 50 PSF, right? 50, 60, whatever you want. Reducible, yes. Partition load, partition means these walls, usually they are 10 pounds per square feet. Construction live load, during the construction, how much load, you will be walking on top of the slabs, so we need to account your weight. Okay, it's usually 25 pounds per square feet, that's commonly used. Mass dead load is basically our total dead load which is responsible for seismic load. By this time in your 488, I'm not sure whether you have done seismic base shear calculation. Have you done that? Okay. Anyway, seismic loads are basically a proportion of your self weight. Okay? It's an inertia force, right? Why? Because seismic load is what? Seismic force is basically the ground shakes with an acceleration, right? So the force is mass times acceleration. Where is the mass? Your weight. The building weight is the mass. So that's the weight we are talking about for seismic force, which is the same as dead load, which is 75 PSF. Okay, I'll add that, and I'll say okay. Also, I want to give a line load, which is the wall load, perimeter wall. All buildings should have a perimeter wall, and that's 0.18. Keep part with. I'm talking about this wall. It's a per square feet is 15 pounds per square feet, and 12 feet high is 180 pounds per linear feet, which is 0.18. Keep it. Okay. And it's not reducible or doesn't matter. Add. And we'll say okay. Now, since I defined the loads, I will apply the loads. Loads go now surface load. It's now yellow. And I'm saying that this is my floor load. and I'm going to add the whole floor load in my whole diaphragm everywhere. Add it. Okay. And also I want to give this line load. This is my line load, and add to the whole perimeter. That's perimeter. Okay. Loads are done. Okay. Now what is next is foundations. Okay. Before I go to the foundations, what I will do is I will do two things. I will make another level for the roof and another one on the first floor. Okay. And I will copy the typical for the roof and for the first floor. Do you understand why I'm doing that? Because roof has a different live load, and floors will have a different live load. Plus the floors will, first floor will have a different live load. Plus the first floor will have the foundations below that. Okay. Now, for foundation, if you place them in typical, it will count it at the bottom level also. So don't worry. If you place it on the, if you place the foundations on the typical level, that's also fine. Okay. I'm sitting here. Let me stand. Yes.
Can you show the numbers for the slab dead load again?
Oh, okay.
Yeah.
This one. And in the meantime, let me drink some water. Oh, no. I'm talking non-stop. So, okay. Is it working? Let me see. Oh, the movie is good. Any question? I'm just taking a 2-minute break. That's why. Any question? Nothing? What was the dream? What was the dream? Just saw that. Okay. Let me stand actually. Sitting all the time. Okay. Cancel. So what I'm going to do is add few more layers. Two floor system. One is roof, and the other one is first floor. Okay. So select the roof. There is nothing here. So what we are going to do is layout, type, copy for the typical everything to my roof. So everything is done. Okay. And since I need to change the surface load, this one I will just say that it's a roof. Everything remains same, only this one becomes 20 PSF and it will be a roof live load. And I'm going to add that. Okay.
Again? The copy and
Which one?
the copy to roof.
Okay. I will do that for the first floor. Will it work?
Yeah.
Okay. So once we are done, then go to layout, loads. Remember, this one has a floor load. Show. If you see, this is a surface load, which is this one. I need to change, delete that one. Right click and add the roof load. Changed. So that's why I said do one and then just modify later. Okay. So my roof load is done, and actually my roof is done. Now also I need to change something on the first floor level, right? Luis, look, you can go layout, type, select, and then you can select from here, first floor, or you can just go here, go first and click on that. Again, there is nothing. So again, go layout, type, now copy, okay, and you are going to copy everything from the typical and say all of them and say okay, right? That was the question for you. Okay. Now only thing for here, I need to give the foundations, right? Are you with me? I need to give the foundations. Remember, for the foundations, what I need is, there are two types of foundations that we will provide. Unfortunately, we will not be able to provide matte foundation here. I just recently designed two matte foundations. One matte foundations a couple of weeks back. So with RAM concept, it's not like RAM structural. Anyway, for gravity, those green columns or blue columns, or what is that color? Cyan? Cyan columns. It's not blue or green, cyan columns. That's not turquoise, right?
It's probably cyan.
More cyan, right? Single column. For those cyan columns, I will add single column foundation. So, go layout, foundation, single, add, and I'm going to use the default, and either you can use a single, it will place a column there, or if you right click and say fence, look, I'm doing all the blue ones, not the red ones. Any blue left? This one, right? Anything? There is one. There's one. Done, right? Okay. For the red ones, I will go layout, foundations, and give a continuous foundation. The reason is, red ones have a lot of lateral loads, so one single footing, if it moves laterally, it will come out. If I have combined footing, then if it tries to come out, the other column will put it back. Will say, don't go. That's the reason. So foundations, continuous, add. I'm going to use the default values. Okay, I am done. Okay, good so far. Now my building has the loads, everything defined. Only thing remaining is, I have not defined the braces yet, and also I have not shown the layers like first floor, second floor, third floor. So now let's define those, the layers, and then once I have the layers defined, then I will go to an elevation view and place my braces. Okay, so let's go to there. How much time do I have? Oh, I have 2 hours. This can run a long time.
Oh, you just put your battery.
Oh, you are saying that my class. Oh, no. I'm saying that the batteries. Sorry. Did I scare you? Come on, I have to stay 2 hours with this guy. Okay, first floor. I'll just say first, and type of floor is this one. And I'm saying that first floor, usually we have a a bit higher, larger depth, or deeper first floor, 15 feet, floor to floor height, and we'll just say add. Second floor becomes second, and that is a typical floor. And that is 12 feet usually. Add. Third, typical. Only thing in the change is I will change splice. Splice means after the third floor level, I will change my column size. That's what splicing means. I can change my column size. Usually my columns come, the members come about 40 feet, almost like 45, 40 feet. So 24, 12, 15, which is 39 feet. Yeah. That makes sense. So I'll just say typical add. It says splicing, that means it's going to change. Typical, no splicing again. Typical, no splicing again. Sixth, let's make it the roof. Okay? Okay. Okay. Now, if I see, that's my building. Good?
Can you repeat again, why did you change the size of the columns? Usually that's in practice we do that.
Yes.
You change after what
The
level?
columns, it's still members, right? So it's still members comes around like 40 feet, 30 to 40 feet,
Okay.
45 feet. The reason is only that you have to use 18 wheelers to bring it. So they have a limit on their space, about 40 feet. So 40 feet means you have like a 15 feet first floor, 12 feet, another 12 feet. So it's about 39 feet. So after third floor, in any way, you have to add a new member. So if you have to add a new member, okay, you have to change the member. Why not we change the member? Okay, why not we use a smaller column size? Because that column size above third floor does not have to take all the loads.
Just takes a roof and whatever.
Yeah, whatever above it.
Okay.
So it can be reduced.
Thank you.
That's why. Okay. The only thing remaining is this needs to be braced frames. Okay. I have not defined it yet, but I need to define it. Yes.
Would you make the floor height?
The first floor.
Yeah.
Take a picture. Now I am all about picture. Take a picture. I don't have to define it.
Third floor had splicing. Why was that one the only one that received splicing?
That's just explained. After third floor, we can change the column shape, column size. Now, these floor heights, it depends on the architectural design, right? Architect wants whether it's a 10 feet high floor or 12 feet high, it's up to the architect. You follow the architect's rule. Okay, now I need to define my braces here. So as I mentioned, the braces needs to be defined on an elevation view. So click on the elevation, okay, and click on this one, it will come up like that. Now I need to define braces, so if I say go layout, now braces, these are not horizontal braces, these are vertical braces now. And if you can use standard ones, these are commonly used. If you add, you can have this one, inverted V, whatever you want. Okay, we just received a apartment. I just saw an apartment which has an inverted V. Well, not inverted, it's a V, inverted chevron. Commonly, we use this one, chevrons. Okay, your SRC buildings, all the braces are actually chevron braces. Am I right? I think so. And your KSI, usually for braces we use HSS rectangle sections, okay, commonly. Sometimes we use white line sections, but it's kind of like a difficult. because your braces are all in compression or tension. Tension doesn't have a problem, but when it is compression, you want it to buckle or bend in a way that you can define. Now, if you place a wide flange section, just like your column designs, it will buckle about weak axis, right? Right? But if you have a rectangle section, both the sections are same. So it does not have a weak axis or strong axis, both are same axis, particularly if it is a square column, square HSS shape. So that's why we want that. Now for a HSS square, my yield strength is actually 46 KSI instead of 50. And I can do a fence. Okay, done that. Okay, only remember one thing is I see a lot of times students do that. You place brace up to first floor and there is nothing on the ground floor or on the first floor. That is a major mistake. Your brace has to be going all the way down to the foundation. It has to dump all the load to the foundation, not to the floor. So it has to be on the foundation level, and actually RAM will give you a warning. Okay, and at the same time, even though I have not defined any of the column shapes or beam shapes because it will be designed, but for the braces, since it's a lateral member, I have to give a size. Otherwise, it will give you a warning. Okay, no, actually, it will give me an error sign. Let's give a brace size. Assign size. And as I said, I will use rectangle HSS section, maybe a 10 by 10. The thickest one, okay, 10 by 10 by 3/4 is kind of like that thick. Okay, this is more heavier than your 18 by something. Okay, I'll give this one just to make sure that my braces will work. I defined it, it's not showing, but how can I see that? Click on this button, shows me that. Okay, I have not defined any of the beam sizes or column sizes, that's fine. Now I will go back because that's only this one is defined. I need to define this one, and this one. I will keep this one out without defining the sizes just to make sure that you understand, or just to show you that it will give you an error. This one, I'm going to give the same brace sizes at standard. This one, fence, layout, brace, size, already defined. There. Go back, check this one, add braces, standard. Okay, and layout. Man, I'm so hungry now. Okay. Okay, this one, layout, braces at standard. Okay, I'm not going to give the sizes now. I want to show you that it will give you an error. Okay, so far my model is done. Loading is done, only thing that I have not given is the brace size. Other than that, it's model is done. So how do I know that it's actually worked? If my model has a problem error, it will never run the beam module or anything. So you have to make sure that your model is correct. Okay, it's called data check. What is that one?
What are those? What are the vertical continuous? The lateral beams that are vertical. What are those?
These ones?
Again? Yeah.
These are moment frames like this.
Moment frames. Okay.
Yeah.
So we don't brace them.
No, you don't brace. I mean, you can if you want a bracement. I'm just giving in one direction I have moment frames, in another direction I have brace frames, just to
And that was just
give
an
you
arbitrary.
an idea
Okay.
what we expect. You'll see that. Okay. Data check. Integrated means it's gravity and frame. If I click on that, 24 errors. Okay. And if you want to see the errors, brace number 13 has no member size assigned. So all of these braces are not assigned sizes. So if you do not assign any size, it will give you an error. So let's go back. Let's give a size. Now do that. No errors. Warnings. Yes. Frame columns are warnings. But that's not a problem for me. Okay? And I want to keep it with like that, the warnings. Okay? As long as I do not have an error, I'm fine. Okay? I want to keep it with the warnings because look at the warnings. All of the frame columns, frame beams are actually given. If you see the warnings, it's like frame column 39 has no member size assigned. It's just the frame columns, frame beams. Okay? Frame beam, nothing else. And I want to keep the frame beams and frame columns open right now because when I'm doing the analysis, frame analysis, I will give the sizes. That's where I can manipulate or I can control that. Can you follow me? If I give a size now, I have to change it there. So, but it will run. How much time did I spend for? How much time do I have actually?
2 hours.
10 minutes only?
10 minutes.
Okay. So if I close it, okay, just one more look. Now you can see the braces, moment frames. If you want to see from the bottom, that's also possible. Oh, the way I'm doing is the arrow buttons, like right, left, those buttons. That's how I use them. Okay, looks good. So now, next stop, once it should give you a green bar when the model is done. Now is the beam designs. How long will it take for the beam to design? The model takes 1 hour.
2 minutes.
2 minutes?
I don't know.
Okay, count. Say 1, 2, 3. Well, not now.
Okay.
I'll tell you. Actually, I'm designing it, but I'll have to change it now. Your beam designs are done. Okay.
Oh.
I just want to change. Then I'll tell you to count. Steel codes. LRFD, LRFD. Good. 360 means our 14th edition. Remember chapter 16.1 dash something? That's actually AIS's 360-10. That's specification. Okay. Okay. Still defaults. That's are fine. All deflection criteria, I will use the default. You probably have that seen in your senior design. Live load L over 360 and total dead load plus live load L over 240. I'll say just camber, composite. Camber means steel beams are very elastic, right? So once you place them, they will kind of like do like that because of the self weight and the dead load. So what we do is we order the members like that. Okay, so once they are loaded, they become straight. So that small portion is called cambering. Okay, most of the gravity beams are like that. So once we have that, once the dead load is there, it will be straight. Otherwise, your beam will be like that if you don't give a camber. So maximum camber we allow is about 2 inch, and that's for composite and non-composite both. We will allow that. Okay, now I will say design out, count.
1, 2, 3, 4.
Done.
7.
Sorry. That's your beam designs. All the beam sizes. Okay. 12 by 19, smaller size, 12 by 21 by 15 because these are girders, taking a lot of load.
Put your house in there.
Okay. If you want to see the roof level, same. 12 by 19s. Can you read them? Okay, you can read them.
What is C?
C means camber,
Camber, okay.
right? Say for example this beam is a 12 by 19 beam, 1 inch camber required, and within bracket is 10 means there are 10 studs required. 10 stud means those bolts which actually keep the concrete and the beam and together. Okay. Once we are in the last week, I'll tell you a lot about the studs.
And the camber is accounting for the live load too.
Cambers?
Yeah.
Usually cambers are calculated based on the dead load.
Oh, okay.
Live load is not that much important.
Okay.
Okay. Look, your dead load is 80 pounds plus additional. Your live load is 40 pounds plus its reduction. So it's about like 30 pounds basically. And live load is here and then it's not there. So camber is only for dead load. And what about the first floor? Well, first floor doesn't have any changes, so same. Okay. So beams are done. You will have a green light columns. Okay. Again, we are designing the gravity columns. Steel design codes. Again, it's LRFD. It's fine. All of them are default values are there. Fine. Trial groups. Remember, as I mentioned in the class, columns sizes usually W14, 12, and 10. There is no 18, 16, or something else. It's all 12, 10, or if you want to rectangle, that's you can do that. Process, design all. Done. That's the part I love in steel design. You don't have to wait too much. Okay, let's see the column. This column, gravity, or maybe a bigger one. Let's say this one. Column size 12 by 40 or on the upper 3 floors. That's where the splicing comes to play. And lower 3 floors, 12 by 65. Okay. What is the load on the column? If you want to see, let's say I want to look at this one and I want to see what is the result. You can see, by the way, this is academic license, so obviously this is not the one. The load on my column is, demand is 412 kip. Okay? Right? With 1.2, 1.6 and 1.5. That's the load combination. And my phi PNX is a 814 kip and phi PNY is 727 kip. Obviously it's larger than 412. So remember, in our class I said maybe 50-20% more, doesn't matter. Okay? It's actually almost 200% more. Well, it has a little bit of axial capacities and it's required with the moment. Okay? So basically that's my column designs are done. Now column design, I will go into the ramp frame where my lateral designs have to be there. Bear with me and take pictures. Okay? All I need now, I'm going to give the loading for the seismic loading Okay, and you will see the load cases. Seismic loading is AISC 710 equivalent lateral force method, and I'll give a name. Okay, and I will add X direction is 8 special moment frames, Y direction is 8 special concentric brace frame. Importance factor is 1.25. Soil site classification. Somebody asked me that one. Soil site classification. Oh, baby, he's not here. Is D. SS is 1.93 and S1 is 0.69. Now these two numbers are actually coming for Northridge, specifically Northridge area from our geological USGS map. Okay, so this is our seismic parameters S and S1. Period of the building is fine. Category is building 3. If it is a hospital, it would be category 4, and in that case your importance factor would be 1.5. Since it is an office building, it's category 3 and importance is 1.25.
What would a residential be? What would a residential be?
Category 2.
Alright. And what would the importance be?
1.
Okay.
Residential, what type of residential? If you are saying condominium like
1-story
15
house.
story, that's at 1.25.
1-story house.
1 story is baby stuff. Your Professor Yadagari's speech is like Q. Baby stuff. Okay. No, it's 1. Okay. I heard that he says Q in his class. Is it true?
Yeah, it's
Wait.
Consider orthogonal effects. That's one thing that important, because remember, orthogonal, what does it mean? Orthogonal effects. I have one moment frame and one brace frame crossing each other. That means that particular column has a moment frame in this direction, brace frame in this direction. For that reason, I have to have this condition, which adds another 12 more cases. So these are load cases, 16 load cases. Let's give some wind also. Define ASC 710 and add. I do not need to change anything because it's already set up for California. So another wind load cases. Done. Okay. So let's do analyze. I'll select all the load cases to analyze. Okay. Can I take this out?
Yeah.
Okay. There was a slight instability. Okay. The reason is my column sizes are very low. Okay. Don't go. I'm not done. I'm just starting. Okay. All I need is, let's say, I will assign column size a little bit larger one, which is it's only the lateral columns, not the gravity ones. Okay, you'll see that the gravity ones will not be affected. And also I will assign my beams a little bit larger ones. Only the gravity ones. Okay? Should be fine. Hopefully. Let's pray for that. Which one? Unstable structure detected.
Fifth story.
So he's working with them. Nice. Gets mad. Or get mad.
You get this one. Sure.
Yeah, we're done. I think we should be okay. Let me see whether, did we give any specific load? No. Sorry, hold on a second. Now it's okay. The reason was beam to column connections was pin connections. So it has to be, moment frames cannot have a pin connection. It has to be a rigid connection. Okay? Sorry for that. Anyway, so let's see the dance now. Okay, process results deflected shape. Okay, this is my deflected shape. I want to show animation, and let's start with the 200%. Load case. Okay, this is how your building will go. Don't worry, it's 200% more. That's 20 times. Okay. Now this is x direction, this way, right? What about y direction? Huh. Interesting is, if you see, I want to show you a couple of things. X plus 0.3 on. Look how it's moving. Instead of moving this way, it's actually moving a little bit on that side, right? A little bit diagonally. Can you see that? That's because it has a significant torsion coming into that place. Okay, it's not moving like that. That means that building has a torsional, not irregularity, but torsion is a big issue for that building. Okay. Okay, we'll need to stop here, and the rest of the you can figure it out by yourself. Thank you. Sorry for that. And can you turn on the lights? The professor is there.
Yeah.
Okay.